Hello, I'm Aaron, and this is my FRQ4 video. So for part A, we're asked to block 1 is replaced by block 2 and has the same material, but block 2 has more mass, and they're both compressed the same distance. And we have to indicate if the position of block 2 will be less or equal or greater than 3D, which is the position of block 1, and we can say that the position will be less than the position of block 1. And we could say this because since both blocks are released from same distance in spring, they will have the same amount of energy. However, since the mass of the second block is greater, the friction component will be larger and cause it to lose more energy to the surface, and this causes it to slow down faster and stop before 3D. For part B, we're asked to starting with the conservation of energy or work energy principle, derive an equation for the position x2, and we express in these constants and variables. And we can start with MEI, and this MEF. So we have a spring, so we start with the potential energy of the spring, and that's 1/2 K delta x squared equals, and it's doing work on a thing, and work is equal to force times distance. And so to find the force of friction, we could do a free body diagram. We have a Fn, mg, and ff. You write friction is equal to mu Fn, and here we can write that Fn is equal to mg, and we could plug in mg into this, and we get friction is equal to mu mg, and plug that in here. And distance is x2. Software, we divide by mu mg, and we get and that's our equation for part B. And so for part C, we're asked to justify if the expression we derived for part B is consistent with our claim in part A. So we could say that in part A, we said that x2 would be less than 3D, and this is true because if we increase the mass of object, it will cause energy to increase the denominator and make the denominator bigger, and this causes the equation to decrease. This means that the distance traveled will be less when the object is heavier. That's part C.